To the application problems. All right, so you guys need to know what these equations mean. Okay, this equation is going to be used for compounding interest. When we're talking about money and investments, this is what we use when per year there's different timing to compound. Daily, annually, semi-annually, anything like that. This equation is going to be whenever you see the keyword continuously. If anything is compounded I had to think about that for a second. Continuously, you will use your PERT model. And then this is for growth and decay. K is our rate, where it changes the growth of the decay. It changes the population to make it either larger or smaller. Okay, so let's move on to number 11. How long will it take for an investment, we're going to use one of these, okay, to double if it earns 15% compounded? There's our keyword continuously, rounded 3 decimal places. So since I am compounding continuously, I know right away I'm going to be using my PERT model. Okay, so now I want to kind of go through and see if I understand, what does the A mean? What does the P mean? E is going to be the exponential value that never changes. Do I know the rate? Do I know the time? Okay, our main question here is how long. So I know I'm going to figure this out. So in this sentence that we have here, I should have an A value, I should have a P value, and an R. Okay, if we take a look, I'm looking at how long will it take for an investment to double. Okay, A is that end value, how my investment's going to change. So if it's going to be double, it's going to be 2 times the amount that it was. If I don't know the exact amount, I can think of P as that's my initial value, as a 1. Because if my A value is 2 times it, I need to multiply that by 2. So I don't even have to put anything for P. If you would like to, sure, put a 1. All right, now my rate is 15%, but I cannot write that as 15%. I need to write it as a decimal. So 0.15 times T. So I have everything I need except for T. Now I need this, and I know from what we've previously done, in order to solve for T, I can add my natural logs onto both sides to bring my exponent down. So I'm going to have the natural log of 2 equals, I'm going to bring this down, so I have 0.15 T times the natural log of E. And again, natural log of E means 1. So I can cancel that out, but it's not a 0, it's not really canceling, it's just turning into a 1. All right, and then I'm going to divide this side by 0.15, so this can cancel out and leave T alone. And so since I do it to one side, I have to do it to the other. So then you want to just go ahead and throw in the natural log of 2 divided by 0.15 into your calculator, and you should get 4.621 years. Right. Number 12. The size of a small herbivore population obeys the function. So this is the function that they're already given to us. After how many years, I'm going to look for time, will the population reach 2,000? So this is already given to me. My initial value, exponential doesn't change. I have my rate, I have my time. And I want to know when the population reaches. Okay, so when it actually changes to become this. Any changed value is going to be on this side. So I'm going to plug in 2,000. And then I know that I need to solve for T, so I need this whole thing to become alone first. So I got to divide by 300. Then I'm going to be left with 20 over 3 equals E times a 0.22 times T. I need to add my natural logs on both sides. And once I do that, I can bring this in front. Okay, so I have 0.22 times T. Natural log of E equals the natural log of 20 divided by 3. Whoops. And if you did plug that into the calculator and you already got some sort of decimal, that's totally fine. But you can keep it like this because you can plug it all into the calculator at the same time. So this is going to go away, and I'm going to divide by 0.22 on both sides. So t then is going to be about 8.623 years. And the last one, I have a fossilized leaf that contains 55% of its normal amount of carbon, which has a half-life of 5,600 years. So this should say years, okay? Using carbon dating, how old is the fossil? So we have to figure out the K value first. We don't know the rate of change that's occurring. So we're going to use this information here to figure out what the K value is. Because this carbon-14, that's how our fossils are dated. That's how we understand how it's decayed and how long it's been. So half-life, just like we kind of did up in the first problem, when something was doubled, the amount after it grew doubled. Half-life is decay. We're talking about a decay problem. So we have some amount of carbon-14, but we want to figure out when it's decaying, when it completely turns into 1/2. So we're using our model, our growth model, which I'll go up here. Okay, we're using this model right up here. But I don't need to know the the initial value, but I do need to know that this half-life, okay, that means that everything was cut in half. So no matter what the initial value was, it's been cut in half at the end. So e to the k, and this is my time, 5,600. Okay, so then I'm going to add my natural log of 1/2, and that's going to equal k times 5,600 times the natural log, natural log of e, which is 1. So that's going to go away. So I'm going to divide both sides by 5,600. Let me erase that. Sorry about that. And then plug this into your calculator. And you'll get that your K value is negative 0.000124. So that's your K value. That's not what you're just looking for, though. You actually want to find how old is the fossil. So now I want to use the information regarding the fossil with my new value, and then I can figure out the time. Okay, so I know that I'm using the model A equals A to the O, E to the KT. My A and A sub 0 value. You can think of this two ways. If it's 55%, we know that 55% is left over. And the initial value, since this is a fossil, would have been 100%. So if you need to think about it that way, then please do. 1, 2, 4, that should be negative, and we'll figure out what t is. Okay, right away, if you know that 55% is 0.55, that is so great, and you can completely skip this step. But if you're not really understanding what we do with that 55%, think of a fossil when something first dies. It's at 100%, and then it's going to continue to decay over time. So there's only 55% left over. So once I do divide 55 by 100, I'm left with 0.55. And that's going to equal, now I'm going to bring down my exponent and add natural log to both sides. Zero, 1, 2, 4. Okay, so now over here we have natural log of 0.55 equals, oh, I'm going to have no room. Let me just try to move this. Okay. So then I'm going to have my negative 0.000124 t, which would be the natural log of e, but that's going to cancel out. So I'm going to leave that off. I'm going to divide both sides by this number, 0.00124. So then t is alone. So in your calculator, you should be typing natural log of 0.55 divided by negative 0.000124. And then you should get that t is going to be about, let me see, 4,821.27 years. That is a horrible there. All right, there you go. All right, so hopefully this helps. These problems that I have done for you on here, if you feel very confident and comfortable with these, I promise you, you will do so well on the test tomorrow. If you need any extra help at all, please email me. Come see me in the morning. Any free periods, I'm in numeracy second hour. All right, but good luck. And just one more day, you guys, and then we have break. I will see you.